Hello, my name is Claribong Inchen, and now me and my group member going to present about chapter 7, welding in workshop technology. First of all, what is welding? Welding is a manufacturing process used to join material, typically metal or thermoplastic, by melting and fusing them together. This is achieved through the application of the heat, pressure of both, often with the addition of a filler material. The resulting joint can be as strong or stronger than the base material themselves, and making welding a critical technique in construction, manufacturing, and repair. And now, this is the type of welding we are gonna to share with you guys, which is gas metal arc welding, GMAW, and GTAW stand for gas tungsten arc welding. So, what is GMAW and GTAW? GMAW, also known as MIG, which is metal in a gas welding, is a continuously fed consumable wire electrode. An electric arc formed between the wire and the workpiece, melting the wire and the base metal to create the weld. Meanwhile, GTAW, known as TIG, tungsten inert gas welding, it uses a non-consumable tungsten electrode to create the arc. The welder can add filler metal manually if needed. The arc is protected by an inert gas, usually argon. GMAW uses a continuously fed consumable wire electrode that melt to form the weld. An arc is created between the wire and the workpiece. And the welding machine for GMAW is the typically utilized constant voltage machine that automatically adjusts the wire feed speed. And GMAW commonly use a mixture of argon and carbon dioxide, and it can providing good protections against contamination. Besides, the filler material is the same as the wire electrode, which is melt during the process to join the base material.
Now I'm going to talk about the type of current and polarity used by gas metal arc welding GMAW and gas tungsten arc welding GTAW. For gas metal arc welding GMAW, it typically uses direct current with electrode positive polarity. In this configuration, the electrode is positive and the workpiece is negative. For gas tungsten arc welding, it uses direct current with electrode negative polarity for most materials. However, alternating current is often used when welding materials like aluminum and magnesium. For the polarity of gas metal arc welding, it promotes a better penetration and a stable arc. This is because the positive electrode heats the workpiece and the negative workpiece pulls electrons, ensuring good melting and fusion. For gas tungsten arc welding, the polarity, which is electronegative, results in better heat transfer to the workpiece, which enhance penetration, making it ideal for thicker materials. For aluminum, alternating current is used because it alternates between electrode positive for cleaning and electrode negative, which is for penetration. The positive polarity cleans the outside layer on aluminum, and the negative polarity provides penetration. Next, I'm going to talk about the advantages of gas metal arc welding, GMAW, and gas tungsten arc welding. The advantages for gas metal arc welding, GMAW: it has a high welding speed and deposition rate. It is easier in terms of automation and adaptability for industrial applications. It is also suitable for a wide range of materials and thickness, and it produces less smoke and spatter. The advantages for gas tungsten arc welding, GTAW: it has a high quality, precise welds with excellent control over the heat and weld pool. It is also suitable for thin materials and critical applications, and it is versatile for welding different materials including dissimilar metals. Next, we're going to talk about the disadvantages of gas metal arc welding, GMAW, and gas tungsten arc welding, GTAW. The disadvantages of gas metal arc welding, GMAW: it is more susceptible to environmental factors like wind, and it also has a less control over the heat input compared to GTAW, and it requires clean surfaces and may not perform well on dirty materials. The disadvantages for gas tungsten arc welding, which is slower process with lower deposition rates compared to GMAW, and it also requires a higher skill level to operate more effectively. And lastly, it is more labor intensive and time consuming. Now I'm going to talk about comparison with other arc welding methods. Shielded metal arc welding or stick welding is more portable than both GMAW and GTAW, but has lower precision and is slower. Next is common welding defects and prevention methods. Porosity: the presence of gas pockets within the weld, often caused by insufficient shielding gas, dirty workpieces, or high moisture content in the filler metal. The prevention that we can do is ensure proper shielding gas coverage, clean the workpiece, and use the correct settings for the material. The next common welding defects and prevention methods are as follows. For inadequate penetration, it occurs when the heat is not sufficient to penetrate the base metal properly, leading to weak welds. One of the prevention that we can do is adjusting the welding parameters, which is current, speed, and arc length, and ensure proper joint preparation.
To continue our group presentation today, the next common welding defects is welding spatter. So, spatter is the small droplets of molten metal that are ejected from the weld pool, creating a messy weld and the need for cleaning. So, the prevention are use proper voltage and wire feed speed settings, and adjust the electrode and workpiece angle such as 45 degrees angles. Next is cracking. So cracks can form in the weld metal or heat affected zone, also known as HAZ, due to high stress, rapid cooling, or poor material choice. So the prevention are preheat or post-heat thick sections, use proper filler material, and control cooling rates. Lastly is undercutting, a groove or notch left at the weld toe that weakens the joint. So the prevention are avoid excessive heat input, adjust welding parameters, and maintain proper technique such as maintain the work angle. Finally, we will go through the last part of the presentation, which is types of distortion in welding and how to minimize them. So we have three types of distortion. The first one is linear distortion, which is shrinkage or elongation in the direction of the welds. Secondly, angular distortion, which means warping of the workpiece at the joint, which change the angle between parts. And the last one is volumetric distortion, shrinkage of the entire workpiece due to heat induced expansion and contraction. Here's are some of the minimization techniques. So the first one is preheat and post-heat treatment to minimize thermal stresses and control cooling rates. Second is balanced weld sequence, which staggering welds and using backstep or skip welding techniques can reduce overall distortion. Next is use of fixtures. Holding parts in place with jigs or clamps during welding can prevent warping. And the last one is controlling heat input, reducing the amperage and welding speed to avoid excessive thermal expansion. So in conclusion, Jimao and Jitao are crucial welding process with distinct methods and applications. Jimao is fast and suitable for thin materials using a continuous wire feed and shielding gas. Jitao produce high quality welds for a wide range of metals using a non-consumable tungsten electrode and shielding gas. Both processes require specific equipment and proper maintenance. The type of current and polarity used significantly affect the welding quality. Jimao offers high speed and automation but is limited to ferrous metals and requires external shielding gas. Jitao provides superior weld quality but requires skilled operators and is lower. Common welding defects like porosity, cracks, inclusions, undercuts, lack of fusion, and overlap can be prevented through proper techniques, surface preparation, and equipment maintenance. Welding distortion, such as angular and longitudinal distortion, can be minimized with balanced welding sequence, preheating, and controlled cooling. So that's conclude our group presentation for today. Thank you for watching.